Hi and a very good day. So for this video session, we actually still under single exponential smoothing model discussion, but for this video I will show to you on how to obtain the solution by using solver, right? So what is actually solver? Okay, before this in my previous video I show you on how I select the alpha. Okay, we select, okay, alpha the smoothing constant. Okay, alpha equals to 0.2, alpha equals to 0.6, alpha equals to 0.8. Okay, and then when we choose this particular alpha, we can calculate the MSE. Okay, and depending on which MSE is the lowest, we say that this particular alpha give you the best single exponential smoothing model. Okay, based on the fitted period that we calculate. Okay, and to obtain there is actually another way to assign this alpha value, which is we ask the Excel to calculate the alpha based on the value, based on the condition that the value will minimize the MSE. It means that rather than we choose alpha first, we choose the alpha at the end of the process. Okay, that's what solver. Okay, so in this video I will show you the demo on how, okay, how to use solver to calculate to do single exponential smoothing, right? Okay, the first thing first, okay, the most important part is actually we set up everything first. Okay, we set up means that, okay, you have to, okay, this is why, okay, you can refer my previous video, okay, on how to set up the single exponential smoothing. Okay, and y hat, we need a fitted value here, and then because we want to minimize the MSE, so we need to calculate the MSE. Okay, so error is actually actual minus fitted. Okay, and then we need, okay, okay, square of error, okay, and so on, right? Okay, so okay, for the purpose of fitting the SES based on solver, okay, I set up first, okay, SSQ, the sum of square. Okay, it means that we want to sum all of this after this. Okay, SSQ, and then MSE, the things that we want to minimize. Okay, and then the alpha value. Okay, here this is just an empty cell because we want solver to give the best alpha value after we after the Excel calculate all of this, right? Okay, so let's begin. How to set up? Okay, like my previous video, okay, the y hat 1 is equal to y1, the initial value is the same. Okay, and then we start at t minus 2. Okay, alpha here is this. Okay, so again we need to lock the value, lock the cell, okay, so that the cell will be not change. Okay, plus, okay, times y1 plus, okay, 1 minus this value, right, alpha times y hat, right? Okay, so you can just enter and then drag. Alright, okay, you don't have to worry about Excel give you the same value. Okay, we will see what happened next. Okay, so here you just set up the formula. Okay, actual minus fitted, right? Okay, and then the error square. Okay, just square set up the formula first. Alright, okay, sum of square. Okay, we sum all of this cell. Sorry, okay, escape. Okay, alright, sum. Okay, careful when you do drag and drop. Okay, sum, make sure that the formula is correct. Sum, okay, from G3 until G40. And then the MSE, the formula of MSE is the summation of square arrow, sum of square, okay, over how many observation. Okay, so here SSQ over 38, right? And then let the alpha being an empty cell, because we want Excel to solve what are the value of alpha, what are the possible value, what are the value of alpha when MSE is when we try to minimize MSE. Okay, so this condition we will set in the solver. Okay, which is where is this button, solver. Okay, you go to data tab. Okay, and you see this button here, solver. What if there is no solver button here? Okay, you go to file. Okay, you go to file, and then you have to add in. Okay, so you go to file, option, and then you go add in. Okay, solver add in, click go. Not okay, click go, and then make sure that solver add in is being ticked. Okay, and click OK. Okay, here you will see solver button. Alright, now we are ready to find the best alpha value. Click solver. Okay, click solver. Okay, right. Okay, close. Okay, click solver, sorry. Okay, so solve. Okay, set objective. Okay, what are we trying to set here is, okay, we try to okay, by default, okay, we'll go to max. Okay, we'll try to minimize, so you choose min here, and then this objective should be your MSE cell. Okay, make sure you correctly put this reference. Okay, by changing variable cell, okay, choose this empty alpha cells, and then okay, I delete first the constraint. Okay, so we need to add the constraint because we know that our alpha value should be between 0 and 1. Okay, so you have to add the constraint. Okay, the cell reference is our alpha less than or equals to 1, and click add. And again, our alpha is, okay, greater than or equals to 0. So add, and then click cancel. Right, so now as we can see here, this is the condition that we set up in our solver. Okay, the objective to minimize our MSE, and then this is the constraint of our alpha value. Okay, when you're ready, just click solve. Okay, and click OK. Right, and then you'll get the value of 1. So again, this is how if we want to use solver to pick the best alpha value that minimize our MSE. But again, as we can see here, there is some condition that you need to understand. As example, what if our alpha is equals to 1, right? So let's take a look at our single exponential smoothing formula here. Alright, so what if, okay, what if, alright, okay, what if alpha equals to 1? So when we change, okay, alpha equals, when we place this value, okay, 1 yt plus 1 minus 1 0 ft. So this is actually, okay, as we can see here, it is actually naive model. So when you have alpha equals to 1, when you try to fit SES alpha equals to 1, instead of SES, it is actually giving you the value of naive model. So that's the condition if alpha equals to 1. So you need to understand this concept before you accepting the solver value, right? You can try with another set of data set, and let's take a look at what are the value of solver that you will get, okay, by using different kind of data set. Okay, I think that's all for this video session. If you have any question, you can reply in the comment, or you can ask your respective lecturer during our online discussion. I think that's all for this video. Thank you for listening. Bye.